Great to see you back in this ninth episode of our Neet Chemistry series for 2025 and 2026. I'm your mentor, Sir Chung Tham David, and today we're going to break down one of the most essential and high impact topics, that is redox reactions. From oxidation numbers to electron transfers, we will solve 45 sharp questions that will clear your concepts and boost your problem solving speed. Redox is all about balance, just like your preparation. Give your best and you'll gain more than you imagine. And remember, in every exchange, there's growth, whether it's electrons or effort. And let's power through this together and keep the momentum going. So, without any further ado, we'll start solving the questions. Question number one. The brown ring complex is formulated as iron salt, complex salt. The oxidation number of iron in this complex would be. So here you are asked to find and determine the oxidation state of iron. Iron in this salt, penta-aqua nitrosyl ferrous sulfate, this is the brown ring salt formed during your nitrate ring test. So let us consider the oxidation state of iron Bx. So if I write like this, 1 into X plus 5 times water is a neutrally gone, so 0, 1 into plus 1 oxidation state for nitrosyl, and the sulfate carries minus 2 charge. So after calculation, X results in plus 1 oxidation state. So answer to question number 1 would be option number 1. Question number 2, in which of the following reactions there is no exchange in the valency? So in the reaction where barium oxide reacts with sulfuric acid, there is formation of barium sulfate and hydrogen peroxide. All the atoms are present in the same oxidation state in reactants and in the product. So C would be the answer. There is no change in the valency. Question number 3. The oxidation state of chromium in the final product formed by the reaction between potassium iodide and acidified potassium dichromate is. So you need to write down the ionic reaction to answer the question. From this dichromate, it generates Cr2O7 2 minus plus iodide. You can get the answer from this after balancing chromium, iodine, and water. To balance this, let us write here 7 water molecule. So what is the oxidation state of this change in the oxidation state of chromium? From plus 6, it changes to 3. So the oxidation state of plus 3 is the answer for this question number 3. So I'm going to give you the options here. The options are A, B, C, D. It would be A, plus 3 oxidation state, right? Let us see question number 4. In which of the following pairs there is great difference in the oxidation number of the underlying elements? So oxidation number of nitrogen in nitrogen dioxide, and in its dimeric form it is plus 4. That is the difference in the oxidation state is 0. Whereas in the oxidation number of phosphorus in pentoxide and in the dimeric form P4O10 is also plus 5. The difference is again 0. However, the oxidation number in nitrogen is nitrous oxide. That is in N2O is plus 1, and in nitric oxide it is plus 2. So the difference is 1, and the oxidation number of sulfur in sulfur dioxide is plus 4, and sulfur in sulfur trioxide is plus 6. The difference is plus 2. So sulfur and sulfur in sulfur dioxide and sulfur trioxide with a difference of plus 4 and plus 6. The difference is plus 2. The answer would be D. Moving on to question number 5. A compound of xenon and fluorine is found to have 53.5% of xenon. What is the oxidation number of xenon in this compound? So xenon gives, it has how many percentage? Let us write here 53.5% of xenon, and fluorine, it has 46.5%. So relative number of atoms of xenon, you can estimate from here. That is relative number of xenon, relative number of atoms in the case of xenon would be 53.5 divided by 131.2 because this is the atomic mass of xenon. So answer is 0.4. And in the case of fluorine, you have 46.5 as the abundance. The difference, okay, of this 53.5 from 100 gives 46.5. The atomic mass is 19. Calculate and you get generate 2.4. So the simple ratio of these two is about approximately 6 because when you divide this by zero point 0.4 and when you divide this by zero point 0.4, the answer is 1 is to 6. So the formula of xenon would be Z, sorry, XEF6 and the oxidation state would be in the plus 6 of the oxidation state, and the option for question number 5 would be question number 5. Option D is the correct answer. Question number 6. Atomic number of an element is 22. The highest oxidation exhibited by it in its compound is. So the element in the atomic number 22 is titanium. Electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, and 4s2, 3d2. So the energy of 3d and 4s is very close. It can exhibit plus 4 oxidation state as titanium plus 4. So D4, 6 would be option D. Moving on to question number 7. The reaction in which hydrogen peroxide acts as a reducing agent is. So in silver oxide, the oxidation number of silver is plus 1. And in silver, the oxidation number is 0. There is a gain of electrons, hence hydrogen peroxide act as a reducing agent. Also 7 would be option D. Question number 8. Well, the following reactions, only one is a redox reaction. Identify it. In the redox reaction, oxidation and reduction takes place simultaneously. So this copper sulfide and iron oxide, when mixed together, it generates this product. So oxidation number of copper changes from plus 1 to 0, and oxidation number of sulfur changes from minus 2 to plus 4. So there is an increase and decrease simultaneously. So question number 8 would be option D. Moving on to question number 9, arrange the following in the order of their decreasing electrode potentials given are alkaline earth metals, magnesium, potassium, barium, and calcium. So order of decreasing electrode potential of this magnesium, potassium, barium, and calcium is magnesium, calcium, barium, and potassium. You can refer from the SRP values given in the table, and it can be explained by the standard reduction potential. Just remember and learn by heart. The standard reduction potential of potassium is minus 2.92, and for barium it is minus 2.90, calcium minus 2.87, and magnesium minus 2.37. I have made a mnemonics on this. You can watch the YouTube shorts specially designed for the standard reduction potentials. So highly negative value of reduction, standard reduction potential, it shows the least value of electrode potential. And hence the correct arrangement of this would be magnesium followed by calcium followed by barium. Then the least is potassium. This is the answer. Option D is the answer to question number 9. I hope it's understood. Let us read question number 10. Which of the following statements are correct concerning redox properties? A metal ion for which E naught for the half-life reaction, and this is an oxidation reduction giving you reduced metal. It is very negative. It will be a good reducing agent. Option 2, the oxidizing power of the halogen decreased from chlorine to iodine. 3, the reducing power of hydrogen halides increased from hydrogen chloride to hydrogen iodide. So referring to this question number 10, the reduction reaction is given to you. And for this reaction, high negative value of the standard reduction potential indicates lower reduction potential. That means metal will be a good reducing agent. So remember, stronger reducing agent corresponds to easily available for oxidation. Higher the oxidation potential, lower is the reduction potential. So 1 is correct, 2 is also correct, 3 is also correct. The correct combination of 1, 2, 3, and 1, 2, 3 gives A as the correct answer for question number 10. Question number 11. A negative standard reduction potential means that the redox couple is A, the, okay, you are asked to find A and B. Now, looking at this question, negative standard reduction potential means it is a stronger reducing agent or weaker oxidizing agent, and vice versa. So the answer would be 11, stronger reducing agent or weaker oxidizing agent. A is, okay, A is correct. Then if you see the B, stronger oxidizing agent, weaker oxidizing, this is incorrect. C will be correct. This is the opposite of the first one. So both A and C is the correct answer for question number 11. Let us read to question number 12. If equal volumes of reactants are used, then the number of moles of potassium permanganate used in acidic medium required to completely oxidize 0.5 molar ferric sulfate solution. So both iron 2 and sulfur in the oxidation state of 4 in sulfide can be oxidized to iron 3 and sulfate. Sulfide can change to sulfate respectively, and hence it gives, so when you find the answer, it would be 3 by 5 times the mole of this 0.5. So what is the value of 3 by 5 times 0.5? It would be 1.10, 0.3 molar. Okay. So permanganate gives this reaction after oxidation, permanganate minus after gaining electrons in acidic medium, it gives you manganese ion and water molecule. You need to balance the equation later on. Then iron 2 plus, it gives iron 3 by losing electrons, sulfide changing to sulfate, 2 electrons. So you finally add this reaction and then multiply this with 3 by 5 moles. So the answer gives the reaction combination, let me write here on the top, 3 by 5 times permanganate ion. I'm writing the overall redox reaction here. 24 by 5 hydrogen ion plus iron 2 plus sulfide. You have to give here minus, gives 3 by 5 times of manganese and 12 by 5 times that of water. Okay, how I'm writing here 2 by 5 times, because multiply this 2, which is 12 by 5 times water, plus bring down whatever that is on the right side, it gives your product. Overall product would be a ferric ion and sulfate. So this is the overall redox reaction, and the answer would be A. I'm going in a lengthy way, but you can simply come to the conclusion once you got this 0.3 molar concentration. I hope it's understood. Let us read question number 13. If rod of a metal X is put in a metal ion solution which is blue in color, solution turns colorless. The metal rod and the solution respectively are. So reduction potential of this copper 2 is greater than that of the zinc 2 and the aluminum 3 plus. Thus it can be easily replaced by these ions. And remember, more this solution of copper is blue in color. Okay, so question number 13 option would be both A and C, zinc copper and aluminum copper. Can you count for the color solution of copper? To answer question number 14, let us read. In the reaction between sulfur dioxide and ozone, the equivalent weight of sulfur in the product is. So the sulfur dioxide, when treated with ozone, it is now changing to sulfur trioxide, right? So the oxidation number of this sulfur would change from +4 to +6. You can easily identify from this given equation. Right. So oxidation number change from +4 to +6. Why I'm saying +4? You can find out X here. And this is +6. It changes from +4 to +6. So 2 electrons change means the equivalent weight would be, it is generally given by equivalent weight is equals to molar weight divided by 2. So the answer for question number 14 would be half of the molecular weight. Question number 15. When potassium permanganate reacts with acidified ferrous sulfate, what happens here? Ferrous sulfate is going to be oxidized and potassium permanganate is going to be reduced. So to understand this question, you need to write down the reaction. KMnO4, the sulfuric acid, it gives a salt, potassium sulfate, and manganese sulfate with water and nascent oxygen. Next is this ferrous sulfate salt, FeSO4, when treated with sulfuric acid at this nascent oxygen so as to neutralize it later on. You are adding ferrous sulfate and water. So the oxidation number of this manganese changed from +7 to +2. Okay. Initially it was in what oxidation state? This is in +7 and this has now changed to +2. And oxidation number state of iron is changing from +2 to +3 because it changes from ferrous to ferric. Right. So question number 15 would be A. Let's read question number 16. Consider the following reactions. You are required to find the value of X, Y, and Z in the reaction respectively. So you need to balance the equation. When you balance the equation, what this becomes 2, X becomes 2. And here to maintain the number of coefficients, then carbon, you need to balance later on. Hydrogen, let us balance first. If I write here 16 by 2, it becomes 8. And on the other side, this Z should be also equals to 8. 8 to the 16, that means this becomes 16. Now carbon dioxide, 2Y, then this must be half of the value of Y, 2Y. So if I put a 5, just check whether this becomes 10, right? 5 to the 10. So 2, 5, and 16. 2, 5, and 16 is the answer. X is 2, Y is 5, 16 is Z. This is the answer to question number 16. Let us read question number 17. When chlorine gas reacts with hot and concentrated sodium hydroxide solution, the oxidation number of chlorine changes from. So chlorine when treated with excess of this sodium hydroxide, you can write the reaction and answer the question later on. So sodium hydroxide in excess. What will you get? Sodium chloride salt, sodium chlorate, NaClO3, and water. Okay. So these are the reactants and product. So balance the equation. Chlorine oxidation state is +5 here. And here you have -1. So on reaction with hot and concentrated alkali, a mixture of chloride and chloride is formed. So 0 to -1 and 0 to +5 is the answer to question number 17. Moving on to question number 18, the oxidation state of nitrogen is incorrectly given for which of the following compound? So in the first case, this nitrogen should be in, it should be in -1 oxidation, -3 oxidation state. So this is the incorrect match. A is the answer for question number 18. Others are all correct. Okay, question number 18, 19. Let us see. Standard reduction potential of redox couples are of A2 plus, B2 plus, C2 plus. These are all divalent cations are given 3.5, 0.75, and 0.9. Which of this is best oxidizing agent and reducing agent respectively? So the redox couple with maximum reduction potential will be the best oxidizing agent, and with the minimum reduction potential will be the best reducing agent. So this divalent D plus and C2 will be the answer for question number 19. Hope it's understood. Let us read question number 20. Permanganate in neutral aqueous medium disproportionates to. So this is disproportionation reaction. If you don't write the reaction, you have to answer the question. So first, let us write down the ionic equation in order to answer the question. So right here, water. This reacts with water, it turns to pyrolusite ore and permanganate ion. This was manganate plus hydroxide. So to balance this equation, let us put here 4 by 3, here 2 by 3, and here 1 by 3. Then this becomes 2 by 3. So 2 by 3 moles of permanganate and 1 by 3 mole of this MnO2 would be the answer for question number. For 1 mole of MnO4, the answer would be question number 20 would be A. This much mole, 2 by third, and 1 by third mole of these are the two options given in the option A. Moving on to question number 21. In the standardization of thiosulfate with potassium dichromate using iodimetry, the equivalent weight of potassium dichromate is. So in iodimetry, potassium dichromate liberates iodine from iodides, which is titrated with thiosulfate solution. So potassium dichromate, let us say K2Cr2O7, right? When this is treated with iodide in the presence of acidic medium, it gives your chromium ion and iodine molecule. So here 1 mole of potassium dichromate accepts 6 moles of electrons. And from the formula, you can easily answer equivalent weight is equal to molecular weight divided by 6. The change in the oxidation number corresponds to the answer. Question number 22. The species that undergoes disproportionation in the alkaline medium are. So chlorine reacts with sodium hydroxide giving you sodium chloride and water, and permanganate giving you from permanganate coming from manganate ion changing to permanganate and pyrolusite ore, and nitrogen dioxide can react with water and gives you nitric acid and nitrous acid. All undergo disproportionation reactions. All of these are undergoing disproportionation. This is correct. 23. 1 mole of N2H4 loses 10 moles of electron to form a new compound, assuming that all nitrogen appear in the new compound. What is the oxidation state of nitrogen in Y? What would be the answer to this question? N2H4. N2H4, if this loses 10 electrons, so it now yields N2, and this is in the plus 6 oxidation state. This is Y. So 23 would be C. Question 24. Phosphorus, sulfur, and chlorine argon chlorine undergo disproportionation in which of the following is the correct answer to question number 24? So this phosphorus, sulfur, and chlorine disproportionate in alkaline medium. So B is the answer to question number 24. I hope it's understood. Let us move to question number 25. In which of the following compounds oxygen has highest oxidation state and in which it has the lowest oxidation state? So we are given oxidifluoride, peroxide, hydroxide, potassium oxide, dioxide difluoride. So oxidation number of oxygen OF2 would be plus 2 and potassium oxide would be minus 1 by 2. And in the case of dioxide difluoride would be minus 1. So the answer, let us see to this question number 22, 25 would be, yes, it has the highest, OF2 has the highest oxidation state. C is the correct answer. Lowest would definitely be your potassium oxide. The most powerful oxidizing agent from the following is the equation. In sulfuric acid, sulfur is in the highest oxidation state, that is plus 6. So it is the strongest oxidizing agent. Sulfuric acid is the answer. Question number 27. When sulfur dioxide is passed through acidified solution of potassium dichromate, then chromate sulfate is formed. The change in the valency of chromium is. So you can answer this question by writing the reaction first. K2Cr2 O7. When you treat this with sulfur dioxide gas and sulfuric acid, you are generating potassium salt, potassium sulfate, chromium sulfate, and sulfur trioxide gas with water molecules. So to balance this, you can substitute here 3, 4. Now answer would be it changes the oxide valence of chromium from plus 3 to plus 6 to plus 3. So 6. So the answer for this question would be C. Let us see question number 28. Standard reduction potential of the half reactions are given below. The strongest oxidizing. This is easy. You can judge the answer from the SRP values 28. So higher the value of reduction potential, higher will be the oxidizing power, whereas the lower the value of reduction potential, higher will be the oxidizing power, reducing power. So 28 would be fluorine and iodide. 29, let's read. A gas that acts at 1 atmosphere is bubbled through a solution containing a mixture of 1 molar Y, 1 molar Z at 25 degree, that is room temperature. So if the reduction potential of Z, X and Y and X, then which of the following is the correct answer? So this is the question asked to you. So remember, more the reduction potential, more is the oxidizing power. 29 would be A. Why will oxidize? Why? Because you can see from these values. Question number 29, done. 30. The violet reaction between sodium and water is an example of the ferrous sulfate is oxidized to. Okay, this is the violent reaction between sodium and water. Okay, question is asking, this is an example of, right? Very simple question. This violent reaction between sodium and water, this is an example of redox reaction. You can write the reaction here. Sodium plus water, this is a violent reaction. It gives you free this gas, hydrogen gas, and sodium hydroxide. So oxidation number changes from 0 to plus 1 and so forth, and back to 0. So in this reaction, sodium is oxidized to sodium hydroxide while water is reduced to hydrogen molecule. So 30 would be option C. It's a redox reaction. Question number 31. The equivalent weight of more salt, ferrous sulfate, ammonium sulfate is equal to. So ferrous sulfate is oxidized to ferric sulfate, changing the oxidation number of iron, that is by 1. And hence the equivalent weight of more salt is, it would be m by 1, which is definitely your m. So A would be its molecular weight. This is the answer to question number 31. I hope it's understood. Let's read question number 32. The set of numerical coefficients that balances the equation potassium chromate plus HCl gives potassium dichromate plus KCl plus water. So the coefficients are respectively, you have to balance this and answer the question. You can write it with 2. Balancing is important for this question. 2. So now you have this 2 hydrogen here. Potassium, there is an increment by 2. So the answer for question number 32 would be 22121. D is the answer to question number 32. Let's read question number 33. Thiosulfate reaction. Thiosulfate reaction reacts differently with iodine and bromine in the reactions given below. Which of the following statement justifies the above dual behavior of thiosulfate? So bromine is a strong oxidant and iodine compared to iodine, bromine is a stronger oxidant. This is the answer to question number 33. Clear? Let's read question number 34. The chemical, need to erase this. The chemical that undergoes self-oxidation and reduction in the same reaction is, so in Cannizzaro reaction, the formaldehyde reacts with potassium hydroxide, right? The formaldehyde reacts with potassium hydroxide, giving you methanol and potassium formate. So formaldehyde is getting reduced as well as oxidized. So C is the answer to question number 34. Let's read question number 35. The oxidation number of an element in a compound is evaluated on the basis of certain rules. Which of the following rule is not correct in this respect? It would be the oxidation number of zinc is always plus hydrogen is always plus one is not correct answer for question. Not the correct statement, but the correct answer for question number 35. Fine. Let's read question number 36. Zinc gives hydrogen gas with sulfuric acid, but not with nitric acid. It gives hydrogen gas with both sulfuric acid and HCl. So 36. Zinc gives this hydrogen gas with dilute sulfuric acid and HCl, but not with nitric acid because in nitric acid, nitrate ion is reduced and gives ammonium nitrate, nitrous oxide, nitric oxide, and nitrogen dioxide based on the concentration, that is nitric acid. So this zinc and nitric acid nearly about say 6% when they react. Let us write the reaction here. Zinc when this reacts with nitric acid, say suppose 30, so 6%, let us say. It gives your zinc nitrate and hydrogen, less than hydrogen. And this nitric acid with this hydrogen can also give ammonia. Ammonia then reacts with nitric acid further to give ammonium nitrate. Then if this zinc reacts with nitric acid, it now gives you zinc nitrate, ammonium nitrate, and water. So zinc is on the top position of hydrogen in the electrochemical series. So zinc displays hydrogen from dilute sulfuric acid and HCl with liberation of hydrogen. Zinc plus HCl can gives your zinc sulfate and hydrogen gas. So 36, the correct answer would be A. Okay. Next question number 37. Which of the following elements does not show disproportionation tendency? It would be fluorine. Good. Question number 38. The oxidation number of sulfur in this molecular form of sulfur S8, disulfur difluoride, hydrogen sulfide respectively are 0, +1, and -2. So it would be option A. Question number 39. Let us read. The stronger the oxidizing agent is, the more is the standard reduction potential, and it is the tendency to get itself reduced or more oxidizing power. 39 would be A. A is the answer to question number 39. Let us read question number 40. Which of the following statements are correct for the given reaction? Mercury chloride, tin chloride gives dimercury dichloride and tin tetrachloride. Now, according to this question, based on this given reaction, you have to answer the question. So, more the negative reduction potential, more is the tendency to lose electron, and the reducing power increases as the standard reduction potential becomes more and more negative, right? And this lithium is the strongest reducing agent as because the standard reduction potential of lithium is the most negative. Okay, so compare and contrast these two. 3 would be the answer only. This uh, question number 40. Mercury chloride is reduced to mercury salt. So A 1, 2, 3. Okay, one. All the statements are correct except statement number 3. If 1, 2, and 4 are correct, A is the answer to question number 40. Fine. Moving on to question number 41. The standard reduction potential for copper ion, zinc ion, lithium ion, silver, and hydrogen ion are given below. Choose the strongest reducing agent among the following. So more the negative reduction potential, more is the tendency to lose the electron. The reducing power increases as the standard reduction potential becomes more and more negative. And thus what happens? The lithium is the strongest reducing agent as because as you can look from the SRP values, lithium is the most negative, roughly approximately minus 3.05. So answer to this question number 41 would be option D, lithium. Fine. Let us read question number 42. In the disproportionation reaction given to you, the equivalent mass of the oxidizing agent is. This is the reaction given to you here. You are asked to find the equivalent mass of the oxidizing agent. So let us write the reaction. ClO3 After losing this hydrogen, it now generates an ion, giving you chlorine. What is the oxidation state? 0. Initially, it was plus 5. So x minus 6, x minus 6 equals to minus 1. So x would be plus 5. So x is the oxidation number. Now we can find the equivalent mass by following a relationship. E equals to molecular mass by oxidation number. What is the equivalent mass of this? 85 point, sorry, 84.45 divided by 5. Okay. Now what is the answer for this question? 16.89. Approximately, roughly you get 16.89. Option A will be the answer to question number 40. I hope it's understood. Question number 43. Which of the following behave both as oxidizing and reducing agents? So in sulfur dioxide, the oxidation number of sulfur can increase and decrease. Hence, what can it do now? It can behave as a reducing and oxidizing agent simultaneously. So oxidation number of sulfur varies either from -2 and it can change till +6. So 43, the answer would be sulfur dioxide. That's the most variable oxidation state. 44. Which one of the following statements are correct? Oxidation state of carbon in C3H4 is -4 by 3. It is the average oxidation state. Okay, this is correct. And electrons are never shared in free. This is wrong. So B is the only answer for question number 44. Now, as usual, the last question is left for you to do. Think about the answer and you can answer this question in the comment section. All right, up to this much for today. Thank you for joining up to the end of the class. We shall continue with this session and see you all. Happy learning. See you in the next episode. Thank you.